Hello there, and welcome to Into the Terminal, Episode 9. We're going to talk about disk management today as we start to wrap up our Jumpstart week. And getting ahead of myself in all sorts of ways. My name is Eric, the IT guy Hendricks, and I stayed up way too late playing with Nginx, so bear with me. And joining me, as always, is my esteemed partner in crime, Scott McBrien. So today we're going to continue on our path of Jumpstart Week, and we've done our registration, or we've created a customer portal account. We've installed our virtual machine. We've registered that virtual machine, installed some packages, and today we're going to move into one of the most complicated topics when you're first getting started with Linux, and that's disk management. So, Scott, why don't you give us a quick rundown of what we got going on here? This is our RHEL 8.5 VM from the other day. And we have no audio. Scott and I were literally talking a minute ago.
How about now?
Hey, there we go. Welcome to the show.
Helps if you don't use the mute button. On the screen, you can't see. All right. So, as you mentioned, this is the box that we set up the other day. And what I have done is filled up its disk space. All right. So I did something really dumb and just took a never-ending stream of null characters and shoved it into a file called big file, and it used up all my disk, right? So when I create a new thing like copy, it can't do stuff because there's no space left on the device. So that's where we're at.
Okay, so we might, if we've got multiple partitions, we may need to know which partition is currently full. So the first command we want to cover today is a command called df. And if you use df-tac-h, that's kind of ingrained in my muscle memory because that makes it into a human-readable format. So you get megs and you get meg and gig instead of like bytes and kilobytes. So it's just easier to math. So if we look down, we see that the root partition, the slash there about halfway down, is at 100%. So we've used 15 gigs out of 15 gigs. And that's a problem because you never want your root partition to fill up completely because then systems start acting odd as different services try to write files to the disk or copy or do writes, and then things tend to break fairly quickly. So we know which partition we need to increase the size of. Then the next command, Scott, do you want to talk about VGS?
Sure. So remember when we did the install on this machine that we took the defaults, and one of the defaults was that we would create a logical volume to hold our file systems. And that's what you see with the dev mapper RHEL root, is it's telling us that this is a logical volume managed file system. It's on the RHEL volume group, and then the file system logical volume is called root. And what we need to do is we need to grow that file system. And the ability to grow is why the default is to use logical volume management for file systems. But this introduces a whole host of commands to interact with this additional layer of file system complexity that also ultimately gives you the flexibility of doing things like growing, right? So the first thing we're going to do is we're going to check to see if there's any free space in our volume group. So VGS will just give a short display of the volume groups on the machine, right? And we only have one RHEL. It is made up of two physical volumes, which are like disks or partitions. It currently hosts two logical volumes, which is file systems on it. And then the attributes we're not going to get into. The current size total is 20 gigs of disk space. And we have almost 5 gigabytes of that 20 gig as free. Right? So this is a really good situation to be in because we can take some of this 4 or 5 gigabytes of free space and allocate it to our full file system, making it larger and now having more free space in it.
So, do you often build your partitions with a little bit of buffer like this, or do you tend to just allocate 100%?
Um, so a good question. It depends. Um, when we installed this machine, um, we went in and we adjusted some of the sizes on the default file systems so that there was free space left over on the disk. And that free space left over on the disk, I actually took a little bit of setup this morning and added it to the volume group so that we would have this extra space. If you do more complex file system layouts, right, where we looked at security requirements, right, where some of the security standards require all your file systems to be on separate devices. In a situation like that, I think it's really important to have some unallocated free space so that you can fill any of those as needed to adjust them over time. Um, for something like a simplistic one like this, uh, you would have to maybe add a disk or something else if you let it use up all of the disk space allocated to it. So I
Yes.
like to keep a little bit in reserve, but that's probably the built-in suspenders me.
Yeah, there's definitely different ways to do this because when I was a sysadmin, I was usually the all in kind of guy. I just allocate everything all at once and go from there. So we are in a good spot though because Scott did keep a little bit of storage in reserve, so we can go ahead and add that to our root partition here. So to do that, we want to grow the size of our logical volume. So to do so, we want to use LV extend. So that's logical volume extend, and then we want to designate the name of our logical volume. This is absolutely amazing because you don't have to go out and buy bigger disks and add them to your RAID array. I could share horror stories about bare metal servers that ran out of disk space. But with logical volumes, it's great because you can grow logical volumes very easily and and allocate space where your applications need them.
Yeah, and I know that there's an option that I need. I want to say it's minus capital L, but it's escaping my memory at the moment. Do you
You're
happen to
trying
know
to
it,
do
Eric?
like 100% free or something like that.
I was just going to do 2 gigs.
2 gig. Is that one
I
a
think it's
lowercase l?
I think it's like this.
You might be right. I think lowercase l may be extents, which we won't cover today. Can create archive name.
I wonder if that's a problem with try lowercase l. Oh, so that one is for extents. And LV extend.
That you may have the wrong device name because actually you could do it LV resize. That may
I don't think I want LV resize.
you can do a dash capital L plus 2 gigs and then the logical volume.
Yeah, let's see if and maybe it's the device that I'm referring to.
Sure.
So mapper root. Oh, and I have the
Oh,
wrong option again.
right.
Nope, still no.
Interesting.
I wonder if the real problem is my big file. 1 second. I can't even use tab completion.
And there we go. All right, let's try it again.
Well, yeah. So I'm going to go back to my original capital L with dev rel root. And it worked. And more
Oh, that's what it
examples of why you
was.
don't want your slash file system to fill up.
Right. Yeah, if this were varlog or something, it's usually more forgiving. But considering this is the partition where the operating system is basically running out of, yeah, it really makes for some interesting troubleshooting at times here. Um,
All right. So let me do one thing to kind of reestablish our admittedly fake example,
right.
fake-ish
Although not as
example.
fake as you might think. I've had applications be deployed into production with the debug flag on. so the logs can grow 15 gigs overnight easy. So
Um,
not as crazy as one might think. Oh, it was worth a shot.
yeah.
Pay no attention to the man behind the curtain. We are professionals.
Helps. All right. So let's see if that'll get us back to that 15 gig sized. Oh, no, I don't want 15 gig. Hold on. Okay. Actually, that's about where we were. No, it was
Yeah,
not. Okay.
I think that gets us close enough.
Close enough? Okay. All close enough.
Well, what's another 3 gigs? There we go.
Yeah, between friends.
All right. So now, as we pick ourselves up off the ground here, so one thing that in a perfect world we would have been able to demonstrate very easily is the fact that just because we increase the size of our logical volume does not actually mean that that new storage space is ready to use. So with logical volumes, you have multiple layers of logic, for lack of a better term. You've got your physical disks, you've got your virtual groups, then you've got your logical volumes, and that's what we just resized. We increase the size of our logical volume. And so what we're going to want to do now is we have to grow the final layer, and that is the actual file system itself. And we could do that with an XFS command. Because this is formatted as an XFS file system. If we do XFS underscore grow FS and then the name of our logical volume, we can actually increase the size to the full extent of the logical volume. So it's an
Okay. And
incredibly simple command, but it's very dangerous in the fact that if you run that over the top of an existing partition, um, actually no, that's not GrowFS. GrowFS is fairly safe, but if you do if you do just a makeFS, then you can overwrite things. But
yeah, make a fuss
GrowFS
pretty
is
bad.
GrowFS is usually a fairly safe operation to run. Although I always get goosebumps every time I run it on a production system. It's like this is the time I want to run a command I know and it's going to break.
So let me just point out what we did there. So you'll notice that up in my DF output that we looked at earlier, even after I grew the volume group, the file system size was still 15 gig, right?
Mhm.
Even though I had added that extra 2 gig to it, um, the file system didn't grow. So, like, I added more disk, but I didn't add the file system format, which is how we store and retrieve files, across that new 2 gigs of disk space that we added. And so that's what the GrowFS is doing, is it's pushing that file system format across that newly allocated raw space. So that now when I do a df-h, right, we show 17 gigs of space instead of 15 gigs of space. So we've formatted and included that extra 2 gig that we added before.
All right, so we have 48% of space free on our root partition now, so we have some room to breathe. But as you can see, that space can get eaten up very, very quickly. So in the world of virtual machines and cloud servers, it's much easier to go about adding additional disk space. You're really constrained by whether you have a storage area network device, a SAN, or if you've got a hypervisor that's got a bunch of storage on it. So what we can actually do with a virtual machine is add virtual disks, which is essentially virtually plugging in an additional hard drive to a virtual machine so we can make that space available as well. So again, we're using VirtualBox mostly because it's kind of ubiquitous across platforms and it's free to use. It's easy to get started with. So if we go into the settings on the virtual machine, we can walk through that process of adding a disk.
Yeah, so we'll go to the storage, and you'll have to bear with me as course, I didn't practice doing this at all. Notice that it doesn't allow me to do anything. All these buttons are grayed out, right? So I can't actually add a disk yet. Why do you think that is, Eric?
Well, my guess is probably because the virtual machine is still running.
Ding ding. So let me go ahead and shut this guy down. Okay, and now all that stuff is able to be clicked, right? So you can't add new disks to a machine that's already running with VirtualBox by default. So we're going to go over to the SATA controller. We're going to add a new storage, a hard disk.
So you'll
add a
want
new
to click
one.
add. Yeah.
Or no, actually, I think I want to click create.
Oh, was there a create button? Yeah, create.
Yeah, there we go. All right.
I blame Eighth Doctor. He led you astray, not me.
It's always a doctor's fault.
Right.
All right, so it's roughly 10 gig. Okay, and then we'll choose it. All right, so now we've got 2 disks attached. Okay, and let's boot it back up.
Gosh, I think I started using VirtualBox when it was like 3 or version 3 or 4. It's been around for a good long time. And Eighth Doctor's coming after us in the chat, but he doesn't. He's not on video, so he can't defend himself.
Well, I will say that some of us remember when it was called Sun VirtualBox.
Yeah, that's true. It's all right, Eighth Doctor. We love you, and we're glad you're here. And not just because you bail us out of confusing issues.
Well, and his ButterFS knowledge is second to none.
This is very true. I didn't even realize Initech had it. Interesting.
Okay. So just to level set where we're at, and make this a little bit larger for us to see. Okay. Maybe.
I think you had to change the display settings in the server.
I did. At some point, we'll figure out how to make that persistent. Ooh, that's too big.
I think we did 1200 by.
Well, not so big. My mouse is also like slow. All right, so 1280 by 800, I think.
Yeah, I think so.
Okay. All right, that's a little bit better.
Much, much better.
Okay, so here we are with our 17 gigs of slash file system. If I do a VGS, we've got our roughly 3 gigs still free in it, but we added that second disk drive and we don't see that reflected here. What command might we look at to see where that is?
So the next command we want to look at is fdisk. And if we do an fdisk-l, that's a list. It'll actually give us an output of all the different partitions. Although I think you wanted to point out something a little bit different because this.
Yeah, so but this shows me all of the disk devices, including those logical volumes, and that's a change
Mhm.
of behavior in newer versions of RHEL. Like if you look at RHEL 6, you would see a slightly different output. So what I like to use to get started is a proc file,
There you go. I'm just used to
proc
scrolling through all the
partitions.
noise to look for what I'm trying to find. It's not the best
Right,
practice.
and as a new person, it's really hard to know what's noise and what's not noise, right?
Right.
So if we look at it, SDA was our original disk. There's a couple partitions on it, and then SDB, that's our new disk that we added. So if we do a fdisk -L on dev SDA, that's our original disk and its partitions. And if we do an fdisk -L on dev SDB, right, there's our new disk, about 10-ish gig, but there are no partitions on it yet.
So we can actually go ahead and create a partition table on the device using fdisk. And so instead of the -L, we want to actually call the disk itself, so dev SDB, and that'll bring us into an kind of the fdisk, not a subterminal. I don't remember what I'm trying to say, but brings us into the fdisk utility itself. Words are hard. So if we do a m, it'll show us all the different options that we can use in here, and maybe blow that terminal up a little bit. There we go.
As big as it's
Perfect.
going to get.
Yeah, perfect. So towards the top, you can see that we can delete partitions. We can list known partition types. Obviously, add and print. Print is the same thing as list. So the easiest thing to do is just on a blank disk is go ahead and create a new partition. So if we type in here, it'll actually give us a wizard, and it'll ask us how do we want to create this partition. So if we'll use primary today. The primary is the default, so you can either just hit enter or hit P and enter if you want to be a bit of a control freak like myself. I don't. I worry about the defaults. We'll take there aren't any other partitions on this disk, so we'll take the default of it being the first partition on the disk.
And one point of clarity there, Eric. So when choosing between primary and extended, you are limited to 4 primary partitions on a disk. So if you think this disk is going to be more than 4 partitions, then at some point one of those 4 has to be an extended, which is how you create the 5th, 6th, 7th, and onward partitions. So with the ease of access to storage today, I think we're getting less and less partition heavy on
Mm-hmm.
disks, right? We can be okay with like 1 or 3 partitions, but if you need to go beyond, an extended partition is how you do that.
Right. Pretty much all the systems I have here at home have 1 or 2 actual partitions on the disk. Everything else is managed by Logical Volume Manager. So I may have 5 or 6 or 8 logical volumes, but only a couple of only a couple of partitions on the disk itself. So Scott, I will admit that sectors are something that has escaped my understanding. Do you want to give a high level explanation of what it is?
Sure. So disks are round, or at least traditionally the spinning rust, it's round, right? So the way that they allocated space was actually like slices off of that disk, like pie slices, and the pie slices were chopped up into even smaller bits called sectors. And so that's what fdisk is exposing to you, is that method of space management. And if we kind of like disconnect from the idea of spinning rust, what you're really looking at is the disk has a certain size, and you're going to start your partition at one spot on the disk, and you're going to end the partition on another spot of the disk, right? So what it's asking us is to define where that partition is going to start and stop, which ultimately will determine the size of that partition. So the first available space for it to start on this disk is at sector 2048. So I'm just going to take that as the default. and then where do you want the partition to end? And you could type in the last sector if you know how to calculate sectors. But notice there's also a plus a number and then K, M, G, T, or P. So if I wanted, I could say, let's do plus 8 gig. And so that way fdisk figures out, okay, based off the sector size of this disk, here's how many sectors it would take to get you up to 8 gig.
And if we do a P, we can see what the result of that was. And I never thought of it as like a circular pie. That's a great explanation. I'm learning a lot of things doing this show. having done this for 10 years, it's like I still learn things. It's great. So we now have a partition on our disk. Is there anything else we want to do here before we exit out, Scott?
Well, we need to be careful about how we exit out of the tool.
Right. Yeah, if you just do an exit, that actually won't write your changes. So you want to use the W command, and that actually writes your changes to the partition table. And then nothing jumps out at us saying error or failure, so we should be in good shape here. And you notice that when we do a write, it actually exits for us. So we're back on our local host terminal. So now we've got a partition on our disk. So the next thing we want to do is we need to prep this particular set of new space for use in LVM. So now that we've got go ahead.
So I do want to do one thing in between because we chose fdisk. There are other partitioning utilities we can use too.
Mm-hmm.
There's one from GNU called Parted that we could use. But because we chose to use fdisk, which is a little bit older, if you edit the disk that the slash file system is stored on, just writing your changes may not actually reflect that in the kernel. So there's a command called partprobe that will tell the kernel to reread the partition tables on all of its disks, and that'll make sure that the kernel's information is up to date with what's actually stored on the disk.
That's a great point. All right. So now that I've misspoken again, we're ready to prep the space for use in Logic Volume Manager. So the way to remember is the way to remember the series of commands is physical, virtual, logical. So you're going more and more abstract as you go down the list. So the first thing we want to do is do a PV create. So now that we've identified the new partition on the new disk as a physical volume, that then allows it to communicate with the volume groups. So if we do a volume group, we can now assign a name to it. So one of the things that I'll do is I'll have an OS disk or an OS volume group, and then if I have a web app or something that's going to have have some space. If I have a web app or something that's going to use, gosh, Eighth Doctor is trying to convert us from fdisk to gdisk or parted. Anyway, if you've got if you've got multiple physical volumes, what I'll usually do is I'll have an OS disk, which is usually I give the name of the server it's running on, and then if I've got something extra, I standardize my systems to be like a volume group data, so like VG data for a name. So if we do a VG create.
Well, so before we get in there, Eric, remember earlier we looked at a command called VGS, which showed us our volume group status. Well, it turns out, just like you were talking about the layers, the physical layer, the volume group layer, and the logical volume layer, there's a PVS. So that'll report on all of your physical volumes. And you can see that devsdb1 here is now a physical volume, not assigned to any volume group. So that's what you want to do with your next step, right, is to assign it to the volume group? Or are we creating a new volume group?
Either way, you got the keyboard.
Let's grow our existing volume group.
Sounds great. So you can either do a VG create to create a new volume group, but today we're going to go ahead and work in our existing volume group. So if we just do a VG extend on, what was it, RHEL? Yeah. So that'll add the new physical volume to our existing volume group. So now if we run a VGS, which will show us the status of our volume groups without the slash.
I got it eventually.
We'll get there. we can see that new space is now available. So the last step, do we want to extend the root partition, or do we want to create a new partition?
Well, we already extended the root file system, so why don't we create a new logical volume?
Okay. So when we're creating a new logic volume, one of the things that we need to be aware of is that that logical volume needs a mount point, and that's basically a directory on the system that's that basically is sort of the bridge between the logical volume and the actual data that's going to sit on top of it. So in a lot of our examples, we've had say slash student, or I think it was slash data slash student. So why don't we go ahead and recreate that directory and create a makedir slash data slash student. So now what we can do is we can create a logical volume called student. That way we know what logical volume talks to which logical volume talks to which mount point. So if we give it a -n, that allows us to give it a name, and then we can do a capital L to define how big we want it to be. There's a nice trick that if you want, there's a nice trick out there that you can do 100% and then free in all capital letters. That'll take up the entirety of that of the available space in that volume group. But like Scott said, we want to be conservative here. This is a new system. We don't know what applications or what uses are going to be the most heavy. So let's go ahead and just allocate 5 gigs right now. And then the last argument in the command is the volume group that we want this logical volume to live in. So now if we do I think it's an LVS, to do a logical volume status. What's really nice about these 3 commands is they have actions within them that are the same across the board. So PV create, VG create, LV create, LVS, VGS. It's the same pretty much across the board for the 3 commands. So it is a lot to take in, it is a lot to understand, but once you dive in, it's much easier to understand. So now we see that we've got a logical volume of 5 gigs called student as part of the RHEL volume group. But we're not quite done yet. We've got, I think, 2 more actions we need to take before we can actually write to this new logical volume. So we've got our mount point created, but before we can actually mount the logical volume, we have to give it a file system. And so that's that we can use a command from the XFS family again, or a makefs. But XFS is a little bit of a shortcut, because you can do an XFS and then I think it's maybe I'm wrong.
Yeah, I think we want to do it mkfs-t.
Oh, I know what it is. It's a makefs.xfs. That's what I was thinking of. Or you can do like Scott said and do a makefs space -t and then define your file system. So this will actually write a file system to our logical volume, and this can take some time if you've got something that's in the range of a terabyte or bigger. I noticed fdisk now had understanding of petabytes, so that P option. But we've got 5 gigs, so it was almost immediate. So last step, we need to actually mount the logical volume to our mount point that we created. So specify the dev, the volume group, and then the logical volume, and then we want it to mount to dev student. So if we go ahead and mount that, now we can actually write files to that file system. Yeah, if we do a df-h, we can actually check our work and make sure that that's actually there. But I have a feeling that this won't survive a reboot.
Well, the data will survive the reboot. but the having it attached into our directory structure won't survive a reboot.
So to fix that issue, we need to edit a configuration file in the etc directory. Etc is where pretty much all the configuration for the system lives. It's called fstab. It's a file system table, I believe.
Correct.
So if we edit the file system table, fstab file, you'll see that our existing root partitions here, the boot partition, the boot partitions here, and then some swap space. So we want to list dev mapper, and then it's volume group dash logical volume. The mount point we want it to mount to, what the file system is, and then for this example, we'll take the defaults and 0 space 0. That has to do with file system checking, and we may get into that in a future episode. But for now, just take the defaults and 0 space 0. And now, if we rebooted our system, we would still get that data student file system mounted to our file system tree.
And we could actually check that without a reboot if you would like.
Right. So a lot of times I will skip a step and do and just go straight to straight. Geez, I'm losing it here. A lot of times I'll skip a step and not use the mount command when I'm going through this process, but instead I'll go ahead and add it to the fstab file. So if you do an unmount of data/student, that file system will no longer be available. But if we use the mount command again, but use a mount-a, that tells the system that we want to reread the entire etc fstab file. And so now if we do a df-h again, we'll see that once again that /data/student file system is again mounted on our system.
So 8th Doctor asks about systemctl daemon reload. So systemctl is what does attach the file systems at boot by reading the etc fstab. But a mount-a will also mount all of the automatically mounted file systems from etc fstab. So as long as the mount-a is successful, then when you reboot, when systemd goes through to add the file systems and reads the etc fstab, it will be fine. You could go through the systemd route if you wanted, but this is the more traditional method and works across all Red Hat Enterprise Linux versions.
Great question. All right, so that was an exciting look at disk management. It's as difficult as it was to explain, but it's one of those things that after you've added 50, 100 disks, it does become muscle memory. As long as you can remember physical, volume, logical. Just think of going from concrete to abstract, and you'll remember the order that those three commands come in. Scott, any closing thoughts before we wrap for today?
No, I think we're good, Eric.
Awesome. All right, so thank you so much for joining us. This was a lesson in live demos as much as it was in disk management. So join Scott McBrien tonight for Into the Terminal Dark Mode, where he'll go through this, and we'll see if it's a smoother presentation or if it's worse. And then tomorrow we wrap up Jumpstart Week by talking about I believe it's networking. So we'll talk about network cards and how to administrate them from your operating system. Until then, like, subscribe, share. If you do those three things, you'll help grow the show. We've had a growing audience, and we're really excited about about folks that have been hanging out and asking questions or feeding us commands that we've forgotten. With that said, thank you so much for joining us today, and we'll see you tomorrow.